Woohoo! This is 9.5. We are simplifying rational expressions, which means there's a fraction, except for there's these crazy polynomials within the expression. So here we go. We are subtracting these two fractions. Before you can subtract, you have to have a common denominator. We have that. They both have n plus 2 times n plus 1. So we can go ahead and subtract the numerators. You only subtract the numerators once you have a common denominator in subtraction problems. So you do need to be careful right here that we are subtracting 5n minus 5. What I like to do is think of that as adding the opposite. So I'm adding a negative 5n, and then if I was subtracting a negative, that's the same as adding a positive. So I took the opposites of each of these. Subtraction is the same as adding the opposite. So negative went to a positive, positive went to a negative. So now I can combine like terms. So on top I have 3n and negative 5n, which is negative 2n, and I have negative 4 that I can combine with 5, and that's positive 1. That's all over n plus 2 times n plus 1. And now I look to see if I can simplify or reduce anything, and I can't. So that's my final answer. Number 2, we're adding fractions. Notice they also have a common denominator already. So that's the least common denominator right here. Now I can add because I'm going to add the numerators together with that common denominator because there's a common denominator. So r plus r is 2r. 2 plus 3 is 5. So my new numerator is 2r plus 5. That's getting divided by r minus 6 times r plus 5. And I can't cancel out anything there. Number 3, I need to make a common denominator. And one way you can do that is by multiplying the denominators together. So I have 4x. That's one of my denominators, and I could multiply that by x plus 4. So this denominator is missing the x plus 4, so I'm going to multiply the bottom by x plus 4 to get a common denominator. But what I have to do on the bottom, I have to do on the top. So I'm going to multiply this 5 with an x and a positive 4. Before I do that, let's go over to the other fraction that we're subtracting off. This x plus 4, to get a common denominator, has to be multiplied with 4x. And I have the x plus 4, I just need to multiply it by the 4x. So I'm going to take 4x. And this 4x is going to get multiplied with the x and the 2. So I'll have to do some distribution here with the 4x to the 2 and to the x. And over on the other side, like I said, I'll have to multiply 5 or distribute 5 with the x and the 4. So on top, I have 5x plus 20 for the first fraction, divided by x plus 4 times 4x. Then I have a subtraction sign. And now let's simplify the right side. I have 4x times x, which is 4x squared, and I have 4x times 2, which is a positive 8x. That's all over the same denominator, x plus 4 times 4x. Now that I have a common denominator, I can subtract the numerators. I can take 5x minus 4x squared plus 8. But again, when we subtract, we need to be careful and realize that we're subtracting off the positive 4x squared and we're subtracting off the 8x, which really I need to acknowledge that they're both, when I add the opposite, it's the same as adding a negative 4x, and it's the same as adding a negative 8x. Sorry, that's negative 4x squared. I'm just saying the squared. So I added the opposite. I distributed the negative to everything over there. So now I combine like terms. I have nothing to combine with the x squared up top. So I have negative 4x squared on top. The negative 8x combines with the positive 5x and makes negative 3x. And then I have a positive 20 still there. That's all over x plus 4 times 4x. Now I need to simplify this, folks. And the process that we've done so far is on the way to simplifying, but one thing we need to check now is that I can't, I need to check out to see if I can factor the top. And when you go to factor the top, it's actually not factorable. You'd be looking for numbers that multiply to negative 80. Where did I get the negative 80? we have a leading coefficient in our trinomial, so I take the -4 and multiply it by 20, which is -80. Looking for numbers that multiply to -80 and add to -3. That's not possible, so it's not factorable. So this is my final answer. If it was factorable, I'd hope that x plus 4 or 4x is a factor so I could cancel it out with the bottom, but I can't. All right. Again, a simple way to do it is to multiply the denominators together to get your least common denominator. Although I shouldn't say least because it's not going to give you a least, but it's necessarily, but it will give you a common denominator. I'll show you what I mean in a little bit. N minus 3, I'm going to multiply the bottom by. But what I multiply the bottom by, I have to do to the top. So I'm going to be distributing the 3n to the n and to the -3. Then, to get a common denominator with this fraction, I have to multiply it by n plus 4. See how my denominators are now the same, n plus 4 times n minus 3, and n minus 3 times n plus 4. I guess I could have read it from right to left like I did the first one too. However, hopefully this one's bothering me right now because I multiplied the bottom by n plus 4, so I need to multiply the top by n plus 4. And that will, the 6n will distribute to both of those. So that first fraction is going to be on top 3n squared minus 9n. And we have the common denominator on the bottom of n minus 3 times n plus 4. Second fraction, I'm going to have 6n squared plus 24n over n minus 3 times n plus 4. These fractions are getting added. So I'll be adding the expressions together. So we get, when I combine the n squareds, I get 9n squared. When I combine the n's, I get 15n all over n minus 3 times n plus 4. Again, try to factor the top. The top we can factor. You always look for a greatest common factor, and it has a greatest common factor of 3n. That would leave me with 3n plus 5. See, if I distribute the 3n in, I get 9n squared and 15n. That's all over that same common denominator. Now I wish that we'd have the same factor here, but that 3n plus 5 does not match with anything on the bottom, so I can't reduce out a factor anywhere. So that's my final answer. And actually, sometimes they'll write this as the answer as well. But you should try to factor the top to see if you can simplify it at all. Alrighty. So here